So we just okay, we just revise once what you have done in the previous class. Okay, let me just check whether you could remember what is IoT. Anyone of you, what do you understand by IoT? So that's the abbreviation. What is the meaning or what is the definition? Or how do you define what is IoT?
By sensor.
Like some definition kind of thing. Like if somebody asks you like what is IoT, so you should be able to define. You should be able to give a definition. So I think last class I gave an introduction about what is IoT, the applications, what devices we are using. So all these things we have discussed briefly. So now I think you would have come to a conclusion what is IoT, but still you should be able to define it. So it's not just like Internet of Things. So what could be the proper definition? See, that is sensors and all, it comes in a secondary part. So before that, you have to define in a proper way. See the word Internet of Things. Okay. So if you could just remember that, so you would be knowing like what is things. Okay, you know like what is Internet, right? So Internet is just like connection of some computers or it's connection of some devices through the Internet. Okay? And things you should know like what is a thing. You should know like what do you mean by thing or how it communicates. So what is thing? How do you define a thing?
Devices.
Yes?
Device.
Device, okay. So yes, device, that could be device or some more definition, some more words. Device is a one word and you could, any other words you could guess. Okay, fine. See, it could be things like I was showing you a lot of things in the last class. If you could remember, like you can just say here, things. Okay, things. These are all like few examples. It's given over here. See, it could be like sensors, or it could be a device, or it could be a smart light. Okay, so anything. So things are something that have a unique IP. Okay. See here, if you just compare these things with the normal things, there is a difference. See, in the IoT, the things will have a unique ID to send and receive the messages. See, if you want to send and receive anything, like assume you are using a mobile, you want to send a message, you need an internet connection, and you will need some device. The device will have a unique identity. It has a MAC ID or it has an IP address. Only then it could send something, okay? And even similarly, the one other device which receives, even it should have some IP address, some MAC ID. So similar to that, so here also things will have some identity, right? Okay. So the things will be having some unique ID. Through that, it will be sending the messages and receiving the messages. So these are the few examples you could see, okay? So that is called as a thing. So you need to understand like what is the things. So things will be interconnected to each other through the internet. So what is it's like defining the things interconnected to each other for sending and receiving the messages through the internet. See, if you are not using through internet, it doesn't become IoT. Okay, getting it? So you have to define using internet. And I just showed you a few more examples in the last class. Like, see, you could see like here, like few things may communicate. Like as given here. Okay, we have to go out for a dinner. Refrigerator is not speaking to the stove. That means see here, refrigerator is trying to communicate with the stove. Okay, using internet. So when they communicate, they will have some sensor or they will have something which has a unique identity. It could be like MAC ID or something. So only then it can send some signal or some messages could be sent and received. Are you getting this? So try to understand. So here in this environment, things will be having some identity, unique identity. Through that, something will be sent and something will be received. Okay, so that is a basic idea of internet. And next here, this is a connectivity, internet. Okay, so internet could be like cellular. That means mobile. I can connect through hotspot, or I can use a Wi-Fi connection. So I can use Wi-Fi, or I can use Ethernet, or like Zigbee, NFC. These are, we have even 6LoWPAN. These are all like protocols for internet. See, it depends on the devices. See, if the devices are small, we need to have like small device. Listen here. See, if the devices are small, we need to have the small protocols like 6LoWPAN, Zigbee, Z-Wave. These are all protocols for connecting to the internet. See, it's not software. See, I'll just I'll give one more example here. Just try to understand like what is this internet, how it could be classified. I'll just try. Actually, here we teach the basics of internet first, but here we will try to go more practical things. Okay. So you can just look at here. So if you just look at this. So these are like theoretical parts. What is IoT? Again, this is some like block diagram. This one. So you are just representing different blocks instead of making it's a sensor or it's a device. Okay. So further, if I just go, so this one. Okay. So you could see here. This is like IoT. Protocol. So protocol is something like to communicate. Okay. So basically you will have some layers like a link layer. So we use like Ethernet, Wi-Fi or WiMAX, LR, low rate wireless power area network. So these are all to get connect with the internet. Okay. And these are all, if you use a Ethernet, we use a cable. We use a coaxial cable or fiber optic cable to get the internet connection. So this is the first layer in this. So it will connect, and then next we have network layer. See this is a protocol like internet, like IP4 version is nothing but internet protocol version 4. Now version 6, and next we have 6LoWPAN, low personal area network. That is for small devices. Like we use small devices in the IoT like sensors and devices. That needs that protocol. Okay, so protocol is a way like how you are communicating through the internet. It's like communication protocols. We call it as communication. If a device want to communicate through the internet, normally we are using this one, IP4. So even in the Windows, if you just go to the properties of your internet, you could see like you will be getting IP4 version protocol still. So that's the latest version, IP version 6, and still the 6LoWPAN would be for the low power devices. So then we use a transport layer. So transport is your data will be translated to some target. Like example, if I just say www bsnl.com. So your data has to translate to the that server, BSNL server. So that is called as a data package. So here the internet, the data which transfers, it's called as a data packet or datagram. Okay. So it will translate to this TCP, transcription control protocol, or user data protocol. These are two protocols for. See, when you just type www.somewebsite.com, so you will have a web server connected somewhere. Your request will reach to that server. The server will respond. So this is all through the data packets. Okay, so if you are learning, you have a subject called as computer network. If you just go through that, you will come to know like how the data will travel from one source to the other target. Okay. So whenever you use the applications, when you press enter, the request will be sent to the server, the receiving server. The receiving server will send back the response, like it has received the data packet, and then you will be getting it back. So here TCP is the reliable, the most used protocol, whereas UDP is very rarely we use. It's the difference is, so UDP is much faster than TCP, but it's not more reliable. See, once if you hit something www. Your request has to reach to the server, okay, and then the server has to reply back. So that will be tracked in the TCP. Whereas UDP is not bothered whether the data is reaching to the server. Again, we are getting the response, but it is a little bit much faster. Okay, that's it. And finally, the last application layer. So we use a browser, we say like HTTP and some website www.com. Then we will launch that application. Okay. So this like just like how the protocol works. First, we will connect the internet through any of these things, and then it will be through the network layer. We are using only this IP Internet Protocol version 4, and next it will be like TCP or UDP. So finally, you will get this. Okay. So yes.
Same like the WiMAX something like that.
See, WiMAX is out. It's like Wi-Fi. See, we have like Zigbee and then Z-Wave. These are all like just like how we are connecting Wi-Fi. It is already used in abroad many countries. It is being used for the IoT devices. See, we are using Wi-Fi for the normal devices. So for IoT devices, we use like WiMAX or LRWPAN, or we have like Z-Wave, Zigbee. These are the protocols. So it is already being implemented in some other countries. Right now, still here we are not using, but it is being used in other parts of the world. Okay. So this will not go much detail into this. It's just theoretical part. You should know like how what is internet. Okay. So try to just remember like internet we are connecting through a cell phone, or we are using Wi-Fi or any of the medium, and then the things will. Okay, so they will translate the data from one to the other using a unique IP address. Okay, so that you should be able to recall. So this was I think last class. We were discussing about the same thing, like what is this thing. So, okay, so I think we already discussed this. In this, if you could look at this diagram, okay, like how IoT works. So this also I just defined in the last week. Okay, so these are like smart things. Okay, so when something is moving, like all this will be in terms of smart lock, like smart lock, smartphone. So example, if you assume this like somebody is traveling in a car. When you reach the house, the door should welcome you automatically. You will have a smart lock, it will identify through some protocol, and it activates, it opens the door. Once you enter, the smart lights will be there. It will, the lights will be identified like some movement in that area. The lights will on. Again, the temperature also set to some temperature depending on the movement. Okay, so this is actually the okay. Just see here, IoT is next data is collected cloud. Okay, so this starting lines, so that should convey like what is IoT. Okay, So IoT is interconnected of network of physical devices connected to each other through the internet. Things refers to physical objects with a unique IP for sending and receiving the data. And data is collected from the surrounding environment through the sensors. And data is analyzed locally or in the cloud. Locally in the sense in our own systems. Okay, or it could be on the cloud server. So in the cloud we'll have some remote servers. Even we could analyze the data in the cloud. Okay. So devices connected to IoT gateway using different protocols. As I said, like Wi-Fi, Bluetooth, Zigbee. So right now we are using Wi-Fi. So even we could use Bluetooth, Zigbee. It is already used in some parts of the world. These protocols are being used. And next, the applications like smart health, smart home, smart cars. So this will give introduction like what is IoT. Okay. So all you should be able to understand what is IoT, what are the applications, smart healthcare, smart home, smart cars, environment, then wearable gadgets. We can wear the sensors to our body and we can track the changes in our body. Okay. And next, industry applications also we use. Okay. This, okay, try to understand this one and you should be able to define. So what is IoT means at least the starting 3 lines. Okay, the first, second and 3 things. Okay, we should know what is things and what is internet. Okay, fine. Okay, understood, right? So starting 3 lines you can just try to remember. So these are basic things what we covered in the last class. The same thing I am just repeating here. So these like basic components. First, sensors will collect the data. So it will be connected through some network. And next, data will process through the IoT devices. See, we use Arduino board and Raspberry Pi, 2 IoT boards we use. And next, on the interface, you will be getting your output. Okay. So this is just the basic component. Again, this is the applications of IoT. So this also we discussed. And this like why you should learn IoT, all these things. Okay. So we have already discussed in the previous class. So this is all much about applications. So use studies like what is the benefit if you use IoT. This all we will not discuss much detail. And this sensors and actuators. So this is the other part of a basic thing. You all know like sensors will collect data from the surrounding environment. And then actuators are nothing but mechanical sensors. Like it's like motors, like servo motor or some type of motor where mechanical things will be involved. Okay, to pull something, to move something, we use the mechanical thing. That's called as actuator. Sensor is a normal thing. Like we have a IR sensor, PIR sensor, temperature sensor, humidity sensor. Okay, there are a lot of sensors are there. So we will discuss further all one by one. So again, this is about just sensors and actuators. Yeah, thermometer, like your even mobile will have a sensor. Okay? But here we use some this type of sensors, physical sensors. So you could see like we have a alcohol sensor, it detects the alcohol thing, okay? And you have ultrasonic sensor, it will detect the like some ultrasonic waves, okay? And next we have IR or optical sensor. It will detect some movement in the area. And then you have a LDR sensor that will identify some type of light. Gas sensor you have that will detect any leakage in the gas. Okay. And then you have like a gyroscopic sensor that will also detect the distance and the geographical things. And next you have PIR sensor. Okay, that will also detect some movement, warm movement. So usually the automatic opening of doors will be used by the IR and PR sensor. With the help of that, it works. Okay. Next, proximity sensor and IR proximity, photodiode, sense hand. So still, like there are a lot of sensors are available. So we will not go much detail later. Like as we proceed further, we will go. Again, this is just like smart healthcare. Again, these are all also sensors. These are all like glucometer, motion sensor, stress sensor, accelerometer sensor. Okay, so there are a lot of sensors are available. And this is the like wearable sensors, EEG, blood glucose, ECG, motion sensor. Okay, so this all will be a temperature sensor, blood pressure sensor, EEG sensor. So it's all like wearable sensor. We can put on the body, we can put on the clothes. It will identify this like EEG sensor. It will identify any changes in your pressure or stress. A temperature sensor will identify the temperature. Okay, so all these things will be processed through the microcontroller or IoT devices. So we have to use any of the device that will be connected to the sensor, and finally the output could be on the locally, it could be on the device, or it could be somewhere in the cloud. It could be to some doctors can view, or it can viewed on some servers. Okay, so that is the meaning of this. Again, you can see these are all like different types of again sensors. Okay, a lot of sensors for a smart world. Okay. So that's it. I just stop this what we have discussed in the last class. So today we will try to discuss with the IoT device. See, we are using some device to process. Like, see, normally we use a CPU, right? So when you type something to the keyboard, your data has to process through the CPU. CPU will have a processor and it will store in your hard disk. Then you get on the display. It is like input, process, output. So you will use some input through the keyboard. Your data will be in the CPU. There it process and it gets stored. And finally you get on the monitor. But as soon as you type, you will get on the monitor. It's so fast that so within seconds you will be getting in the monitor. But before monitor, it has to process through the CPU. So monitor is only for displaying the data. Nothing will be done inside the monitor. Or I can display on the projector, screen anywhere. Any display unit I can use to display that. But processing will be done in your CPU. That is a normal case. Whereas here also we collect the data from the sensor. It will process through the boards. Like we use IoT boards like Arduino board and Raspberry Pi. So there it will process and then we get the output on the display. So it is similar to how input process output. Here input will be through the sensor and processing will be done using the IoT devices. Because as in your normal CPU, we do not get the pins for the sensor. Like as I explained in the last class, we cannot connect any sensor to your CPU or the laptop. You should have some specific pins for connecting the sensor, but that is not available in your normal devices. We need some IoT devices. So that's we will discuss now, like Raspberry Pi and Arduino board, two devices. So today we will try with this Arduino board. So you can just look at here. So the Arduino board it's like combination of two things. Okay. So you can just look at here. This is the board we are using to process the data, and we are using the IDE. So what do you mean by IDE? So this is integrated development environment. Like we have to write code also. Okay. To write the code, we need some development environment. So if you are using C, C++. We use like C compilers or Moreland C++ compiler. Or if you are using Java, we need Eclipse. Eclipse we can use our NetBeans. Okay, or we can use some other environment for writing the program. Okay, in a similar way, if you are using Python, so we are using Colab. You can use Colab or you can use PyCharm, Spider. There are many platforms are available to write that specific code. Okay. So here also we are writing the code using a Arduino IDE. The name of the IDE itself is a Arduino IDE. It is a open source. It is available freely. If you just go to arduino.cc, you can download it from the website arduino.cc website. You have to download what is your OS. If your OS is Mac, you get a compatible version. If it is Windows, you get that version. Whatever the version you are using in your system, you can download that suitable version. Or even in the Microsoft Play Store. See, even in your Windows, if you are using Microsoft Windows, you will have a Play Store. Even there, this software is available. Okay. So if you could check here. Arduino is an open source hardware and software platform for IoT. So it is hardware as well as software. It is not purely a hardware. We use software also. But the programming will be very less. Okay, we use very less programming here. That's why it's very popularly used by everybody. Even the person without any computer science background, he can easily learn this because not much programming will be involved. Only like basic functions will be involved. Okay. Now next, the most popular IoT device development platform. This is the most popular platform. It allows low cost and easy way to create devices. So your Arduino board is it's a very low cost compared to any of the board. So you want to take motherboard, like your CPU will have motherboard, right? You want to purchase a motherboard, what could be the price? How much you have to spend to purchase a motherboard?
About 10,000.
How much of this?
It can be 10,000 more than that.
So it will be in thousands,
Yeah.
but your Arduino board will be in hundreds. So it will be like 4 to 500. Okay, it was when it started, it was just like 3 to 400, maximum like 500. It comes in a hundreds, and even it supports you the connecting of sensors. See, on the board you will have the pins so that you can connect any type of sensors to that. We can connect a digital sensor, analog sensor. Analog is for measuring. Sometimes we measure something that use a specific pin, analog pin. So that will be available on this board. Function, whatever the code you are writing, so your output will be on the board. This board will be connected to the sensors, and then it works. Are you getting this? What is by in Italy? Masami Banzi is the founder of the Arduino board. Again, these are the developers who developed this board. And see, this is also called as a microcontroller. Okay, microcontroller means so everything like your CPU, your mother. Raspberry Pi stands for Python, Raspberry Python interpreter. So when you go to that, you will learn that clearly. Okay, or you can download the software also. You can or it will be available by default. Still, you will have other software also. Like we have VA editor, we have PyCharm, Gedit. There are many softwares available. By default software to write the Python program. Okay. So code is what you write to function there. See. No, the device should be there. See, because as I said last class, you cannot connect any sensor to the system. Okay, so you need a. So all the things like your processor, RAM, ROM, everything will be soldered on the board. You cannot remove and fix. Whereas in the normal motherboard, you can able to remove and you can able to fix it. And moreover, you don't get this connecting to the sensors in the normal boards. Whereas in the IoT devices, we can do that. So I just will go further. So you can just see here. So this is again. So you need to connect your board to the system. Okay, because the software is available in the system. Okay, so in the system I have to download the software. The software is freely available, open source in the sense. Okay, it's like freely available from everywhere. So you need to just not to pay a single paisa. You just go to the Arduino.cc website. Freely they have released the software. You can download it and install. It hardly takes like 2 to 3 minutes to install that. So that if you install, and then you have to connect your board to this. So we are using this connector. We use this USB cable will be there. That you will be connecting to this system, and then you will integrate the hardware in this. That's the first thing you will do, connection of your board with the system. Once you connect, see, you will be getting power to the board. See, on the board you will have the LEDs. You will have power LED. It will start blinking when you connect. That means we are giving power to the board. Okay, power to the board. So we are not directly connecting to the external device. We are connecting to the system itself because we have to write a program here and we have to upload to the board. We have to write a program and translate the code to the board. See, once you translate the code to the board, can remove this. Okay. Ladder, that is it. You will use first time some software you will use, some system will use. You will connect the board and we call it as uploading of program or transferring of the program. So once if you do that, your program will store to the board. So then you totally can remove the system, even the software you need not to use. So directly you connect your board, whatever the program you have written, it will start executing the program. Your program will be executing from the board. Only first time you have to write it using some software and upload it. Are you getting this? So this is a very important point in the board. You need not to use the software every time. So only one time you write the program. When you upload it, it will store to the Arduino board, and then you can leave this one system. You can remove the system software, and you can just give a power to that. You can use battery cell, or you can use your external charger to give the battery to give power to the board. So if you just give a power, whatever the program you have written, it will start working.
And where is the battery going to install in that?
Pardon?
The battery, you put the battery there. You're going to install the battery somewhere.
See, battery install in the sense you have to connect through wires. You can take the external battery and that should be connected to the board. How you are connecting here? So you are connecting USB type. So here we can connect the battery. Okay. So further we'll discuss the structure of the board. We'll discuss clearly. So any doubts here? So try to understand the basic things how it works.
So this board cannot be installed inside the laptop or PC.
No, board you have to connect it. How will you install it? See, that is, you can connect it. You can connect pair with the system. You can pair it like how Bluetooth you are pairing. So like that, it's a device that will be paired with the system. So once if it is paired, then you write a program and you translate the code to the board. So once if you done, you can remove the software, you can remove the system, your code will be running from that. So like why Arduino is? So it is easy to use platform, easy of programming, simple USB interface and simple IDE. Okay, so this is the just meaning of this. And next, these are all like different types of boards. Okay, so right now in the Arduino, we use the top one, Uno. It's called as the Arduino Uno. We have many types in this. We have like Leonardo, Dio, Micro, Mini, Nano, Lilypad, Explora, Mega. So these are all like various version of the boards. Some boards will be smaller in size, and this is called as a Lilypad version board. It can easily wear on your clothes. The board can be fixed. Okay, so in all this, only there is one difference, number of pins. See, if you use the Uno board, you have like 11 digital pins and 6 analog pins. Around 60 to 70 pins you get. Whereas in other boards, you may get more. You may get 40 pins. So you have this one Mega board that has more number of pins compared to any of the boards. See, what is the use of more pins? Why do you need more number of pins? More connectivity, you can connect more sensors. Okay, if you have less pins, only less sensor we can connect. So that is the difference between this and the memory. So the memory of the Mega board, it will be much higher than this, than the Uno board. Okay, so like this, each board differs in the number of pins for connecting the sensors. Okay, and the memory of the board. Okay, so some memory will be there, and that boards will differentiate, and the size. So even the size you could see from there. The last three are very small, that is Micro, Mini, Nano. See, it's function same thing. Whatever you do with the Uno board, same thing you could do with all these boards. Only the changes is the size, number of pin and the memory. Okay, it will vary from this. So these are all like different types of Arduino boards. And this is the board we are using right now, Arduino Uno board. You could just see here, this is the best board to get started with electronics and coding. So hardware specification, you can see the LAN with microcontroller is nothing but it's like a processor. So what processor are we using in the CPU?
Pentium.
Pentium 1. We are
It
using
was 2.
3, 4.
Yeah, I3,
I3
I5,
we are using.
I7.
First it started from P1, P2,
Yeah,
P3, P4, then we got the DL core, go to
Go to
DL, now I3, I7,
I6.
I5, still I9, I9 also it's coming into the picture now. But here we don't use that Intel or a Celeron processor. We use a different processor. The name is Atmega 328P. It's a processor name. Okay, and you can see 14 digital pins. Top you can see you will get those slots to connect the sensor. See, your sensor will be connected to those pins, and it will be numbered like 0 to 13. Okay, and next bottom you'll have 6 analog pins. Like whenever you want to measure something, we use those pins. And this is a direct connection, power jack. So directly you can connect your power to external resource, or you can connect your battery also to this battery sets, or USB you can use. If you are using USB, you can connect to the system. So this is just a configuration of this board. And next, if you go, you can see this Leonardo has 20 digital pins. So whereas in this board we have like 14 digital and 6 analog. So here 20 digital pins itself we get. So we get only like 0 to 13 in the 13 digital pins, whereas this board will having more number of pins. 20 pins are there. Some boards will be 40 pins. So it depends on the board what we are using and differs in the number of pins. And next Arduino Dio. So that is like first faster processor. See here it uses some 32-bit ARM core microcontroller processor. And next it is 54 digital pins. So earlier we had 13 digital pins, 20. Now your Dio will be having 54 digital pins. That is, you can connect 54 sensors. Okay, next micro. So micro is nothing but like smaller one. Okay. So the size of the board is smaller and it has very less pins compared to the other boards. And even the Arduino Lily pad will be like a flower, and even it has very less number of pins compared to the Uno and other models. Only that's the difference. And this lily pad could be weared on the cloths, on fabrics, easily we can attach on that. And next, Flora. So Flora is it's almost like a game controller. So it has some built-in LEDs. You can just see at the top some LEDs are there. Okay, and even the number of pins. It includes a joystick also. This Arduino board will have a joystick, okay, to move something left, right, okay. It has its built-in temperature sensor, microphone, light sensor. See, it has a built-in sensor in this board. So whereas in other boards we will connect the sensor using the jumper wire. We use a small type of jumper wire to connect your sensor to the pins of the board. And next Arduino Mega. So it's a very advanced board. It has 54 digital pins. It is used for complex project. It's a very advanced board compared to any of this. And next you could see here. So here all these sensors are integrated to the microcontroller. And again there also you will have these actuators, mechanical things like motors, servo engines, servo motors. These are all called actuators. So all this will be integrated to the microcontroller. Okay. You will be connecting to that and then you will be writing the code. So this is a board we are using, Arduino Uno board. You can just look at this. So the clear description of the board is given here. So starting at the top, okay. See, we have first reset button. See why the reset button is. See, when I said like you write a program, when you click the upload button, it will transfer the code to the board. See, in the board, that program will be permanently stored. See, whenever you give connection to the board, the program will be executing. Okay. So if you want to clear that code, if you want to erase the code, we have to use the reset button. So if you hold the reset button for 5 seconds, it will clear the code, whatever the code is there in the microcontroller. So this is your processor, your code will be storing into this. Okay. You have to clear it if you want to write a new program, or you upload a new program, so then it will be into that board. Okay. So we will learn further. When you go, you will be learning how to use it. So try to understand the description. First is reset button, and then you can see 0, 1, 2, 3 to 13. So these are all the digital pins to connect the sensors. And the 0 and 1 is for TX and RX. Do you know what is TX and RX? See, whenever we transmit data from the system to the board, some data will be transferred, some data will be received. So you get this LEDs blinking. So you'll have two LEDs for TX, RX. So that two will be blinking. So 0 and 1 always will not use to connect any sensor. It is for transmitting the data and receiving the data. So you will have a separate program for using the TX and RX. So right now whenever we are coding, 0 and 1 pin we will not use. We will start from 2 to 13. Okay? So any pin 0 and 1 is preferably for transmitting and receiving the data, TX and RX. You will have a LED there, it will start blinking whenever your data is getting transmitted. And next you have this LED power on. See, once if you connect your board to the system through a USB cable, that light should on. You will have a LED on the board. If the LED is not getting on, means the board is corrupted. The board is not working. It has been corrupted. Only if you get light that shows light, the board is in proper use. It's working. The board is working. And next you have the microcontroller. That's a processor. So it is of 8-bit and 16 megahertz, 32 KB flash. See, it has only 32 kilobytes of memory. Okay. So the code will be very much smaller. And when you upload the code, it will show you like how many bytes the code has taken. So you have to write a code using the software. You have to click on upload. If you upload it, it will show like how many bytes memory it has taken out of this 32 KB. And some other boards like Arduino Mega and that, it has 256 KB of memory. Kilobytes, it is not like gigabyte or terabyte. It will be in the terms of kilobytes because the code will be very smaller, almost like some 10 lines, 5 to 6 lines of code. So hardly it takes some very less memory. Now next you have the 6 analog pin. You can see A0, A1, A2. That is to connect your analog sensor. Some sensors will be with for measuring purpose. That should be connected to those analog pins. And next we have power in 9-volt battery. So as I said, you can take power from the battery also. If you have a 9-volt battery, you need not to connect this to the computer. You can directly take a power. Okay. So next is this one, power out. That is, this is for the sensor. See, the sensor will be inactive. When you take a sensor, it doesn't have any power or doesn't have a built-in battery. It will be connected to this. You will have the ground connection here. So that will like 3 volt, 5 volt. Some sensor will be taking 3 volts, some sensor will be 5 volt. We will connect the sensor to this. Then your sensor will be getting the power. So this is like power in and power out. And this is like adapter, okay, direct adapter you can connect, or power 5 volt USB. So this we can connect to the system. Okay. So this is a clear structure of your board. If you want physically have the board, you can just go through this. So first try to understand this, then virtually we will do using the software. You can just go through the same thing, it's there here in the board.
What is the cause of getting the board corrupted? What is the cause of getting the board corrupted?
Short because due to like fluctuations in the power. Just show it to sir. So is it fine? We can just go through this. So right now we will not directly do with the board. We will do with the virtual software. We will have a virtual software for this. So that we will do. Before to that, you just pass on to others. Let them. Will.
What is the name of this book?
The ordinal.
So here, okay, you can look at here.
So according to you, the power cuts like has a corruption.
That means it's not functioning. So it is very rare case it will happen. But most of the time it will be working because what happens sometimes parallelly we will be using. So we have in many number of batches. So continuously the board will be in use. Sometimes like fluctuations may happen in power or something. So then some part of ICs would go. So then it doesn't work. Okay. You can just look at here. So this is your Raspberry Pi board and this is the Arduino board. So I have just compared both the boards here. So you can see here the Raspberry Pi board is also similar to that, but it has much facilities. You can connect the Ethernet cable and you can use Wi-Fi. Built-in Wi-Fi will be there in this Arduino board, and then you can connect camera. 40 pins are there. That is, in the Raspberry Pi board you get 40 pins for connecting input and output sensor. And next, display also you can connect. And this is a processor, ARM-based processor. USB ports. See, 4 USB ports will be there. We can connect the keyboard. You can connect mouse or USB things which you have to connect to the CPU. And that could be connected in the back. You can connect the Ethernet port. Wi-Fi also you get in this, and this is a power connector. So your Raspberry Pi has to be powered with some 5 unit. We use like how we are using to connect the Arduino board. Similar way we use one cable to connect the Raspberry Pi. So this just it's a comparison between this Arduino and Raspberry Pi board. But you will be learning detailing when you go to the Raspberry Pi part. So right now we are discussing only the Arduino board. So try to understand the structure of the board. It will make you easy to understand how to implement this. So board will have specifically the pins, digital and analog pins. Okay. So that you should know to connect your sensors and all the things. Okay. So it is just a rough description about the boards. Okay. Is it fine? Any doubts here? So try to understand. So this is just a specification of the Arduino Uno. So if you are using Uno, you can just say here it's 5 volt it takes, and the input voltage will be 7 to 12 volts, and the pins 14 digital pins, and we have some pins with the till symbol, that is called the pulse width model. PW pulse width model. They are using for some specific purpose. So when you use the board, you will learn about this. And next, analog pins are 6, direct current 40 MVA, and then DC current for 3.3 to 60. And memory, flash memory is only 32 KB, out of which 0.5 KB will be used by the bootloader. Okay. So there is a memory where, and then you have some RAMs like static RAM, and then electronically erasable programmable read-only memory. So these are like ROMs. How we use RAM and ROM in your system. It has built-in ROM and RAM, and the speed of the clock will be 16 megahertz. Okay. So this is for the Arduino Uno. The same thing if I just go further with this mega board. So this is a Arduino mega board. So you could see the pin number starting from 21 to, you can see over top, right side, bottom, everywhere you have the pins. Whereas the Uno board has only at the top and the bottom. The pins will be maximum 20 pins we get, but here we have 50 pins, okay, almost 50 pins we get, and even the processing speed will also be much more than this Arduino Uno. So this is the structure of your Arduino Uno board. Sorry, Arduino Mega. This is Mega 2560. It's also a type of Arduino board. And this is the specification. You can see at Mega some processor we are using. 54 pin we are using in this. 54 pin digital and 16 analog pins. The normal board we are using only 6. So here we are using 60. And flash memory is 256. There we are using 32 kilobytes, and in this it is 256 kilobyte, and it is 16 megahertz. Okay. So this is just the description about the boards.
The speed of both the system are same.
Pardon?
Megahertz, 16 megahertz for the Arduino, for
Okay,
that and this,
Yeah, this is Uno is also 16 megahertz. It's
this is all same. Okay.
Clock speed is same. It's given.
Okay.
And processing speed is not given here. It's only
this
the
is not
clock
there, yeah.
speed they have mentioned.
The clock speed is there.
Yeah, it is same. But much facility will be there in terms of storage and in terms of connecting the sensors. And these are all called as Arduino shields. Okay. See, as I said, like see in this board, see we cannot store more because here it is limited capacity. It is 32 kb only. You know. So 32 kb means kilobyte means what? Okay, 1 byte is equal to 6 bits. That is, if you have 1 byte of memory, you can store 6 letters. So 8 bits it is. 1 byte is equal to
8 bits.
8 bits.
1 byte.
8 bit means 8 letters. See, for a computer, it takes 8 letters means 1 byte memory it will take. So 1 kilobyte means 1000 bytes. That is 1000 letters. If you have 1 kilobyte of memory, 1000 letters you can store in the memory. In a similar way, if you have 1 MB, it is 1000 kilobytes. So like that we will have like megabytes, gigabyte, terabyte. But here the storage is very less. So 32 KB means around like 32,000 letters we can store. 32,000 letters only we can store in the memory. See, we use some plugins. Plugins in the sense on the board itself, you can plug extra, like I want to use an SD card of some 16 GB. So I can use that plugin. So this is called as a Arduino Shield. So Arduino Shield is nothing but as some external part that could be plugged in. I don't have right on the motherboard. So it is on the board itself. On the board itself, this external shield that we can plug there. Okay. So this
Is that the same kind of board can be fixed on the top?
No.
yeah, that is plug-in means it has some pins. It could be plugged on the digital pins or analog pins. Okay, that facility will be there. So these are like some plugins like Arduino Bluetooth shield. This is. So you want there is no Bluetooth available in the Arduino board. If you want, you have to purchase extra this one and you have to plug on the board. Okay, in a similar way, Ethernet shield. See, it has Ethernet port. You can plug that on the board to use the Ethernet in the Arduino board. Okay, in a similar way, Wi-Fi. If you want to use your Wi-Fi, you get extra Wi-Fi shield. You can plug on the board. And this is SD card. You want more storage, you can have SD card. But all this will be built-in available in the Raspberry Pi. You need not to buy extra. Everything will be built in the board itself in the Raspberry Pi. Whereas in Arduino, we do not have all this. We can opt for the shield and we can plug and we can use. And you have a camera shield. You want to use camera, you can have it. So all these things, okay, will be plugged on this. Okay, and next part will be like writing the program. Okay, so getting started. So this is a software, Arduino software. This is so it will look like this. So you can freely download from the Arduino website. So you can download for Linux, Ubuntu, Mac OS, or any of the OS. You can download it. Okay. So this thing which I will start next class.
Okay. Okay, sir.
So if you could get your laptops or something, it will be better, at least like 2 to 1. Okay. So I will show you like how to do virtually with the software. Then we will try to use this. So this just theoretically I will show you. Practically we will do it in the next class. So this is a IDE and this is an editor to write your actual code. Then the software. Once if you download this, when you install, when you open, you will get it like this. So you could see on the top there you have a menu bar, file, edit, sketch, tools. That is for saving, editing, all this. Apart from that, below that you have a toolbar. So in the toolbar, you will have the option for uploading your code. You can just see the first one is verify is nothing but compile.
Okay.
See, once if you write a code, you have to compile the code. When you compile, it will check for errors. Like some standard prerequisite will be there. Whenever you see programming, each statement has to end with a semicolon, and you should not use a capital letter. It is case sensitive. Okay?
Yeah.
Some letters will be caps and some letters will be small. So you cannot use all full capital letters or all small letters. So your compiler will have some keywords built into the compiler. Only that words you have to use. If you are not using that words, the compiler will not understand. It will generate an error. So that verify will show you that. And the next one is upload is for uploading to the board. Okay, so you will be connecting the board to the IDE, that is to the computer. Once if you click on that upload option, so here down it will show here how much memory it has taken and how much code is uploading to the board. It will show you that. Okay. In a similar way, we have new, open, save. These are all toolbars in the IDE software. Okay. So this is a software. Once if you download, you can use it. So I will show you this how to use in the next class. And apart from that, these are all some like board type. Okay. So here, when I go to board, you see like we have many types of boards. We have Arduino, Nano, Mega. You need to select what is the board you are using. So here on this board it's written clearly Arduino Uno. So whatever the board you are using, you will have the name on the board, and that board you have to select. In the tool option, these settings you have to make. Or else board will not be uploaded in the board. You have to select the correct what name is there in the board. You will be listed with all this Mega, then all this board. You have to select the board which you collected. Okay, that's the first step. And next step is port. Okay, see there are many communication ports are there like USB. This we are connecting to USB port. That is called as a communication port. So you may have 2 USB, 4 USBs. So we don't know where this is connected to which communication port. So when you click on the port, it will show you. See now Arduino Uno is connected to communication port 6, COM 6.
Automatically.
Yeah, automatically it will show you. You have to select them. So if you select, then that will, your board will be paired. So you have to pair your board in the software. Okay. So when you are pairing it, first thing you have to select the type of board, whether it's a Uno or a Nano, what board are we using. And next will be the port. Okay. So as I said, like we'll have COM 6, COM 3, many ports will be available in the system. But in one port, your this board will be connected. So you have to select that port. Okay. That's the second step. Next, you have to use this one, get board info. See, when I go to get board info, you get a description of the board. Each board will have a serial number. It has some ID. Okay, so it will show you that. So until you get this information, see when you go to get board info, and if you are not getting the board information, if it is not displaying anything, then your board is not paired with the software. So if your board is not paired with the software, we cannot transfer your code. You have to write a code. We have to upload the code to the board. So that will not be done if you are not getting the board information. To get the board information, so you have to follow these 3 steps. Select the board which you connected, and next select the port, communication port. What port your Arduino board is connected, and then just below that you will have this get board info. So when you click on this, a small pop-up window will appear giving the serial number of the board. As I said, like each device will have its unique identity. So it will show the serial number, then it's working fine. So your board is successfully paired with the software IDE. So then you can write the code and you can follow these steps. Upload, when you, the second option, upload. So when you click on that, your code, whatever you write here, so it will upload to the board. Okay, then you will be getting the output, and from the board you will get the output. You will be connected your sensors to the board. So what are the sensors you are using? So we will be getting that. See, if you connected a sound sensor, you will be getting the sound. So we have buzzer also, buzzer or LED you can connect. If you connect a LED, LED will start glowing. Or if you have connected a buzzer, it will start producing the sound. So like this, we have a lot of sensors are there. So that will start functioning when you upload your code to the board. Because from the board you are giving power to the sensor, right? Understood?
Yes, sir.
So this it's a little bit like you have to follow. It may look difficult, but if you don't follow this, your code will not be executed at any cost. Even if your code is correct without error, you have to first pair your hardware to the communication port, and you should get the get board info. So only then you could able to get the clear output. Okay. So this is the thing. Okay. Any other doubts you can let me know. And again you can see here at the bottom. See, you will be getting this error messages at the bottom of the editor. If it is not connected or if the port is not identified, it will show these errors. So these are all like wrong board selected. If you know is there, you selected some other board. So it will show like the board is different. And uploading, if it is working, you get an option like done uploading. You can see here 110 bytes memory is used out of 14336 bytes. It will show clearly how much memory your code has taken to upload it. Okay, so all this information you could see on the editor here. So this is your editor at the bottom. This is here everything will be shown. Even when you click on verify, if any error is there, it will show like semicolon missing or the statement is unknown. So you can read the statement, you can correct yourself. So code will not be like page wise. See, if you go to any programming, you have to write a lengthy code, but here the code will be reduced. We use only two statements, like a pin mode, digital write. These two keywords we use every time.
Oh.
And we use one more, the system.println, to print some statement on the screen. So maximum these three statements: pin mode, digital write, analog write, and then system.println. So code will be very less, but you have to correctly write where you connected your sensor. See, there will be 13 pins.
Yeah.
If you connected your sensor to the pin 10, in the code I have to write like it is connected to pin 10. You have to mention like it is connected to pin 10 itself. It is not connected to any other pin. So it has to match what you are connecting your hardware to which pin, and in the code also you have to write the same pin. So that we will practice when you write the code. Okay. So we will do it in the next class. So apart from that, these are all still basic things about the IoT, and it's the board we just started. So we use this practically. If you want, I can show you the system also. But preferably we will also do with the simulation software. We have a software for everything where same board we have. Okay. See, physically what you are getting the board virtually, you get virtually in the sense it will be a part of it. It's not exactly the hardware. The same board will be available. You will have the same number of pins. You will be learning how to connect it, how to write the code, and once if you start simulation, you will get the output. So everything will be done. Okay.
What difference between robotics and IoT?
See, robotic also it is done through IoT only. So robotics also it is through some sensors and through some devices.
So can you please?
Okay. Comes up any other doubts?
Can you please just play the videos of the starting for 2 or 3 minutes?
As you told, you need a specific pins to connect to a sensor. But in Node, they use different kind of pins, like you can it can be connected to directly to laptops.
No. It's not like that. In which sensor, the sensor this will be there. No, so in which port you are connecting, we have to.
Robotics will not work. RPA, okay? So it will like some board will be there. Others said there will be lot of types of boards are available. The board will be small or it may be very teeny, but it will be available. Without that, you cannot do anything. So without board. So your board can be connected to system virtually. Like remotely you can connect. So you will keep your board somewhere. You will have a IP address for that. So that you can connect to your system and you can write code here. But you will feel like it's working here. But the board will be.
You can sit, sir. Sound. Thanks. Okay, was you understood everybody? How was this today's class? How was your today's class? How was your today's class? Did you understood? Understood. So it was hard. The new students, it was hard to understand. Come. Okay, so we'll end for the today's class. Okay, so next week all the students requested to just arrange for a laptop so that the lab will be there, the practical will be there, so it will be easy for you to understand. Okay, so arrange and come. Okay, everyone. So with the laptop, if you have a coding, that means sir will show the coding how to, like sir was saying almost. Sir was saying, no, yes, we need to activate. That means need to make a coding. So basically, sir will teach you in that manner. So the coding will be less, in maximum 6 to 10 lines max, because it used as a library. So because of that, okay. So be regular and just if you concentrate, how well you give your feedback. That means how you show your interest. So sir will explain in that depth. Okay. So next week, welcoming. So carry on with laptops, and just who wants to join the class, physical class, just let them know before the class itself. Okay, fine. Thanks a lot for today's class. Okay, thank you. Bye.